So now let's go on with this topic called perimeter. You've done the area. Let's find the perimeter of this sector over here. 2 decimal places. So same concept as before. We're first of all going to do this in 2 parts. The first part, let's find out the whole circumference of the circle. Okay, so the whole circumference of the circle, because when we get that, we're going to divide it by how many parts they are. So here is your sector, 60 degrees. Our radius is obviously 4 centimeters. And let's find the whole circle over here like this. Okay, all right, so this will be pi times d, which will be pi times 8 or 8 pi. That's our circumference. Let's divide this by how many slices they are. Now again, you do 360 divided by 60, it'll be 6 slices over here. So 8 pi divided by 6, this will give you the arc. So the arc is this bit over here. Let's call it this green bit. That's your arc. So that will be 8 pi divided by 6, which will be 4.19 2 decimal places. Now you want to find out, let's say, 3 parts to this. 3 parts comprise of your perimeter. It's the radius, which is 4. This will be the radius as well, plus the arc. So let's find out the radius now. Perhaps we can do a little yellow dot for this. This could be the green one. So the yellow one is simple. It's going to be radius plus radius, 4 plus 4, which is going to be 8 centimeters. So we add the 2 over here, green plus the yellow, which is going to be a total of 12.19 centimeters. So quite a simple question already, but it's just the same idea as the question before, the area, but we're using perimeter to do this. So look back and pause this video to make sure you understand these back to basic questions.
Let's press pause on this basic surface area introductory question, parts A and B, and let's try to find out the surface area of these 2 respective shapes. Press play when you think you have the right answer. So question 1, find the surface area of this cube, side length 4 centimeters. A cube definitely has all the same dimensions, which means the height, the width, the length, all of them are all 4. You don't need to see that to make sure it makes sense. So hence this would be 4, the height. Let's do a quick arrow over here. Height would be 4, the width is 4 as we can see, and the depth would be 4 as well. Now the surface area means, first of all, we need to see how many faces we have. We have 6 faces with any cube or cuboid for that matter. So let's find the area of 1 and then times it by 6. So the area of this square over here, let's just call that a different color. Let's say it's green. This front face over here, let's find out this. This would be simply 4 times 4. So 4 times 4 is 16. And we times that simply by how many faces we have, which is 6. 16 times 6, this is a non-calculated question. You can do short multiplication, but if you do that, you'll get 96 centimeters squared. Remember, this is squared because it's surface area. That's pretty simple. 96 centimeters squared for this cube. Let's do part B now. Part B says find the surface area of this triangular prism. Okay, so this comes up quite often, in fact. Surface area for triangular prism. So there are 5 faces. The first thing to identify is always how many faces you have for surface area. Maybe we can make this look a bit better like this, so you can see. Not too good at drawing, but we can see that. Okay, the 5 faces all together. So let's deal with this. First of all, let's call this front triangle over here, this front face, a triangle. Let's call this front, and let's call the back bit as well, the back. Okay, so front and back. Let's find the area of both of these. The front shape is a triangle, half base times height. Therefore, this would be 3 times 4 divided by 2. 12 divided by 2 is 6, and simply the back face is the same as the front, 6 plus 6. So there are 3 different sections we're going to use over here. You don't have to do it this way, but we suggest a maths memory. You do. We follow the simplest way to do this. Second one over here. So we've got now the front and the back. Let's do the left and the right. So the left is over this bit, over there. It's going to be 3 times 10. Okay, height is 3, and that's 10 over here, which is going to be, let's call it left and right. Left is going to be 30 centimeters squared, and the right is a sloping bit over here, which is 5 times 10, which is 50. All right, the last bit is the base, the bottom bit over here. So the base, let's call that the 5th face. This would simply be 4 times 10. 4 times 10 is 40. Once you have all of those 5 faces, we simply add them up together. So you can do the maths behind this. Well, 30 plus 50 plus 40 plus, let's say, 12, because obviously it's going to be 6 plus 6. 132 centimeters squared is the answer. That's your surface area of this triangular prism over here. So please look through these two answers. They'll hold you in good stead for these questions to come in our core questions. So let's press pause. Let's do another couple of questions, part A and B on this topic of basic volume. Slightly more complicated, but nevertheless needed for this topic. And press play when you're ready. Now here we have a cylinder. Calculate the volume of this cylinder over here. Same principle as a prism. It's like a circular prism. We could say that as well. Let's find out the cross section, which is the front face, or the back face in this case you could say. Okay, this is the cross section over here, and times it by the height or length, which is 10. So simply, as a calculated paper, as we can see over here, it'll be the area of that circle, pi times r squared, and times it by that length. So pi times r squared will be pi times 7 squared. The radius is simply 7, and that whole thing times 10. So we could say 7 squared is 49. 49 pi times 10. On a non-calculator, I guess we could say it's 490 pi. But in this case, on the calculator, let's use it. So 49 pi times 10 to 3 sig figs, 1540 centimeters cubed. Pretty simple. Again, cylinder. This formula with a cylinder will never be given to you as well. Anything involving a cylinder, in fact, surface area or volume of cylinder, never given to you. Okay, let's do part B over here. So calculate the volume of this shape. So the volume of this shape over here now, this is, it could be looking like a, well, quite a weird looking shape. It's like a compound shape, basically. Okay, you may have done this before, maybe 2 or 3 years ago. So let's have a look at this in detail. So the same principle applies. You want to find out the volume of this. It's the cross section of the front face, the cross section of this L looking shape over here. We look at this carefully. The cross section of this over here times the height or length, which is 10. Right, now to do this, to find out the green bit, we need to section this off to 2 bits. It doesn't matter which way you do it. We'll just take these 2 bits over here. We'll look at this rectangle over here. So the height is 5, the width is 2. And then we'll look at this rectangle over here as well. Okay, the height is 2, the width is 6 minus 2, with the width is 4. So let's write those measurements down first of all to 2 and 5. This is 4 over here. Okay, that's 6 minus 2, 6 here, minus the 2 bit over there. And this is simply 2 because of the 2 over there. 5 times 2 is going to be 10. And this is going to be 4 times 2, 8. We add them together. 10 plus 8 is 18. The cross section is 18 centimeters squared. So the answer will be this. It'll be 18 times simply the depth of this, or the height, or length, would be times 10, 180 centimeters cubed. It looks complicated, but it's not. Just figure out the cross section of the front face, as we keep saying, and that's how you do this question over here. So let's get ready for our core exam questions now, which you should be able to do with these back to basic top-ups. So let's do this introductory video on these 3 shapes that come up a lot in this topic, applied formula. You'll see a lot of cones, spheres and cylinders. So let's get back to the basics of understanding what these surface areas and volumes are. So press pause, figure these out, write these as a multiple of pi and on the calculator 3SF if you want to. We'll give you both answers, and press play when you have finished. Now let's find the surface area and volume of this shape. This shape is a cone. So they should give you the formula for this, volume and surface area. Let's show you how to find the surface area. Well, let's call this a total surface area first of all. This is defined as the curved surface area, the curved bit over here that looks like a party hat, and this base, the circular base of this over here. So first of all, the curved surface area, it's pi times r times L. Pi times radius times length. Length is your diagonal bit. So we have the radius, we have the height, which is 4. It looks like this. This is probably a better version, because we always use Pythagoras. It's a right angled triangle over here. We're finding out length. So it's simply pi times 3 times 5. So the curved bit will simply be 3 times 5, 15 pi. That's your curved bit over here. and we simply add the base. Pi r squared, r is 3, 3 squared is 9, plus 9 pi. That's your base. Alright, curve plus base equals your total. So the total would be this, 24 pi. On a non-calculator as a multiple of pi. If you wanted this on the calculator, it'd be 75.4 centimeters squared. Next one, let's find the volume. So the volume is simply a third pi r squared h. So first of all, let's do r. R is 3 squared. 3 squared is 9. 9 times 4, the height is 36. A third of 36 is 12. So the answer is simply going to be 12 pi centimeters cubed this time, or on the calculator 3 sig figs, 37.730 centimeters, 0.7 centimeters cubed. Alright, so look at those questions over here. I'll just highlight these because it's quite hard to see these. This, giving them as multiples of pi and 3 sig figs on the calculator. Okay, surface area of sphere. Again, we're given this. Very simple. 4 times pi times r squared. R is 3. 3 squared is 9. 4 times 9 is 36. 36 pi is a multiple of pi, or calculated 3 sig figs, 113 centimeters squared. Volume, 4 over 3 times pi 3 cubed. 3 cubed is 27. So if you do this on the non-calculator, do 27 times 4 divided by 3. Answer should be 36. So again, we've got 36 pi. Okay, or we could say this, the 3 sig figs, same thing. They're both the same snap, in fact. You can have this, but one's squared and one's cubed. Let's do cylinder. So this is not given to you in the formula booklet. So the surface area of a cylinder, this is quite a tricky one, in fact, or trickier, should we say, than the norm. So surface area, we're going to have 3 parts. Part A, let's say the base. Part B, the top bit. And C, the curved bit in the middle. So A is pi r squared. So pi times 4 squared, 16 pi. So let's call this A, in fact, over here, 16 pi. Let's call B 16 pi as well, because that's the circle on top. And this bit over here, this is your curved bit over here. So if you look at this, this looks like a rectangle. Perhaps we can show it to you over here. So if you like rotate this 90 degrees, this would be, let's say, 10 centimeters over here. And this over here would be your, you got to guess what this is. What does this represent over here? What is this height? This height is the same thing as your this bit here, circle a bit around your circumference. So it's pi times d. Pi times d is simply double radius. You get 8 pi over there. So 80 pi is part C. All right, so this is part C, if you want to call it that. So plus 80 pi. All right, that's part C. Answer is 112 pi centimeters squared, or the 3 sig figs, 352 centimeters squared. Volume. So volume of this, volume is much easier. Cross section times the height, or length, should we say. Cross section is 16 pi. 16 pi times 10 is 160 pi centimeters cubed, or 3 sig figs on the calculator, 503 centimeters cubed. Look back at these. These are very important. You understand this, particularly the cylinder, to work out the surface area and volumes of all of these. We'll highlight all of these over here. This is what you should master in this Back to Basics to carry on with the rest of it. Let's put this, we forgot this over here, centimeters squared, centimeters cubed. There we go.
So let's get down to this topic. This is a more advanced topic on the basic trigonometry you may have learned before. It's 3D versions of different shapes. So you will see the different varieties of shapes during this topic as we go along. And we need to be an expert in basic techniques like Pythagoras, trigonometry, and let's say non-right angle techniques, sine and cosine rule, before we start. So once you've understood those techniques, we can apply those techniques to these kind of shapes. So let's press pause, try to do parts A, B, and C, and press play when you're ready. Now the diagram shows a triangular prism, and this is quite a simple example compared to the questions we'll be doing later on. This topic is not guaranteed to come up in a GCSE, but if you do get this, these are more or less likely to be grade 8 or grade 7, grade 8 topics. So find the length CB. So CB is this length over here, and what we're going to do before we do this is show you a way to identify the right angles anywhere. Now the base is the most important thing on any kind of, let's say, 3D shape. And why is that? Because we have these right angles, which you can imagine if you were standing on top of this shape, a plan should be say, you can see these right angles. I'll just label them over there. Now CB, this is a, let's say, hypotenuse, or we could say label it part C, towards a right angled triangle. Okay, the right angled triangle is over here. This D is the right angle. Okay, so let's always draw a 2D shape to represent this. This is one of the tips and tricks in this topic, to draw a 2D shape to represent the 3D, let's say, calculations you're trying to do. Now, we could do it like this, in fact. Let's do it over here. Let's go to this bit, and let's go back to this. Alright, so we have a nice shape, and we'll label it CDB, and your right angle is over here. So this D represents this D over here. What do we have? DB is 8, and we also have CD. CD is going to be this one over here, which is 3. So it's basic Pythagoras, so it's going to be a squared plus b squared equals c squared. We'll simply call this one of them a, this one b, and this one c. So very, very simple. Once you've drawn it in 2D, we can actually say a squared. We'll do it very quickly over here. In fact, 3 squared plus 8 squared gives you, let's say, cb squared. So 9 plus 64 gives you cb squared. Therefore, we add them together, we get 73. So root 73 equals CB, which therefore would be the value, the three significant figures, 8.54. So that is one of the values CB. And this length of CB is a pivotal value for all the rest of the questions to come. You'll see this as a trait as we go along. So that's going to be part A, how we did that over there. Okay, let's part B. Now everything follows on as we said in 3D trigonometry. So part B, calculate the length of BF. So BF is this line from here right down to over here. So again, what we'll do, always try to draw the triangle on your 3D shape if you can. That's 1, 2, 3. Alright, so we have a nice shape there. We'll call this a little red little dot to signify this, as we did for this yellow one. This is now a red one. And we'll draw this shape over here. So always a 2D representation for the for whatever you're trying to draw over here. So this is what we'll draw. This one, this, and this. And it should be quite apparent what the different letters are. And this is F over here. There we go, this is F. This is C. This right angle is this right angle over here. You see the C over there, and this is B over here. What do we know so far? Well, CB was what we just found out, 8.54. This height over here, FC, well, if EA is 6, FC is going to be 6 as well. Again, we're trying to find out the length of BF, and this is pretty simple because BF would be the same thing as we did in part A, just a Pythagoras kind of question. So we'll label this C. It doesn't matter what A and B are. A and B will do the same thing as we did for part A. Again, there's no trigonometry involved at all. So we can say, let's say 8.54 squared. Try to take the whole number, by the way, to calculate it when you do this. Not just the three significant one we've rounded up over here. Plus 6 squared equals BF squared. So if you do this in a nutshell, basically BF would be this. The same calculation as above. BF would be square root of 10.4 to 3 significant figures. Alright, so not that difficult, it's just the same technique, but the trick is to draw a 2D triangle, as we keep saying, from the 3D shape once you figure it out on here first. So figure it out in your shape first, in your 3D shape, plug it to a 2D version on there. Part C. Now part C, it's this one. Part C says find the angle FBC. Okay, so FBC, let's use this triangle, FBC, FBC. It'll be this one over here, so we'll keep with part B, in fact, this one, the middle one, FBC. Now this is basically trigonometry. We have a right angle triangle, it could be more obvious. So I'll refer to C over here. So C will be this bit. This is part C, plus C as well. This is part C, by the way. Yeah. So it'll be basically opposite, and you've got your adjacent. Opposite is 6, adjacent is 8.54 rather. Trigonometry is going to be tan, so it'll be O divided by A. So 6 over 8.54, that answer, shift tan answer, 3 significant figures, 35.1 degrees. So I skipped a few steps there, but we assume you understand the basics of trigonometry. We won't explain trigonometry again, but that will be 35.1. Okay, that's in green. So all these colors signify different things. Make sure you get your pen down, write this down in your cards, because we'll be using them later on.
Now let's get down to these exam questions and let's focus on trying to put all the 8 theorems, how good is your memory, onto this question. So think of the word key features as well in terms of looking at the question and what pops up to you in your mind, what you identify straight away from that circle, which should link to those 8 theorems. Anyway, press pause, press play when you're finished. A, B, C, D are points on the circumference center O. AOB is a diameter of a circle. CAB is 28 degrees. Now let's look at our key features. What can we see from over here? Well, A, B, C, D. This looks like a cyclic quadrilateral because there are 4 points on a circumference. That could help us. It may not. Anyway, that's a key feature. AOB is a diameter. That could help us. What else? I think that's about it really. So let's look at the questions. Let's delve down into this. X, what is X? So X is over here. Now this is the center of a circle 0 and this is a diameter. So obviously this is a point on the circumference, point B. This is the semicircle theorem. Okay, so all 3, this plus this plus this, have to add up to 180 degrees. This has to be 90 degrees. This angle over here, ACB, is 90. So if we add up all 3, take away from 180, this would be 62 degrees. Again, we'll put semicircle theorem. All right. Again, you elaborate on that, obviously. Y. Now, Y is D over here. Now, Y and X add up to 180 degrees, cyclic quadrilateral. So X plus Y equal to 180. We just said from number 1, part 1 of that 62, 180 take away 62 would be the answer for this. So this would be 118. And we'll write there cyclic quad for short. Part B. So ACD are points on the circumference center 0. AB and CB are tangents. Angle ADC is 50 degrees. So we just said that obviously these are points A, C, D. All right, and we have center O, and these 2 are tangents over here. And that's basically looking at our key features. If you look at this quite carefully, those are key features in these different colors. We could also say OA and OC are the same length, the 2 radii as well. All right, let's get down and delve into this question. Angle AOC. So AOC is over here. AOC, this little one over here, what is that? Now this, again, center, this is circumference, 2 key features. This has got to be double. So AOC, rather, has got to be 100 degrees because angle at the center is double, okay, double angle at circumference, or double angle theorem as we call it. Quite simple. Angle ABC. All right, so from our key features, how can we get this? ABC. So whenever we have, let's say, a tangent from a point over here, this forms a kite. You've got it. Therefore, 290 degrees over here. This, we know, already is 100 degrees. And all 4 angles of any quadrilateral, a kite being a quadrilateral, adds up to 360. So 90 plus 90 is 180. 180 plus 100 is 280. 360 take away 280 would be 80 degrees. So we write it 80 degrees. Reason why, well, I'll just put a kite over here, but you elaborate on that, okay? 360 degrees somewhere, put that into your answer. Angle CAB, CAB. So where's this? Now this is going to be an imaginary line. We need to put this over here, in fact, to make it look a bit better. CAB. This is the one we want to find out. Let's make it a different color. Perhaps we'll make it this one over here. All right, CAB. What's this? Now this is quite easy, obviously. This is the one we want to find out because if you look at this, well, there are a couple of ways of doing this, in fact. Let's look at the first way of doing this. So this is 100 degrees. This forms an isosceles triangle. So this must be 40 here, and this must be 40 as well. Okay, that's 40. Can you just about see that? And that's 40 as well over here. This is 40 as well. So therefore, this is 90 degrees, okay? OAB is 90, because when radii means tangent, it's 90 degrees. Hence, 90 take away 40 must be 50. So the reason could be isosceles triangle and radius means tangent. Or we could say this. I mean, you've probably learned about the alternate segment theorem. You have a triangle over here, CDA. All right, that's a triangle. You got top left, which is 50. Bottom right must be the same. Top left, bottom right. Alternate segment theorem. This must be 50 as well. So either one, you can put that down. I'll put a isosceles triangle though if you want to. But also the alternate segment theorem. In fact, let's do both, and you can make sense of either one that makes sense to you. All right, circle theorems. So let's try these questions yourself. Let's put it to action, what you've learned. Let's look at your key features and your 8 circle theorems. If you have them to mind, put them to paper, and let's try these questions. Press pause and press play for the answers when you're ready. Circle theorems. So let's go through our cards, let's go through your theorems, and let's identify, more importantly, your key features on this circle. We have quite a few theorems over here to get to this angle BAC. So press pause and press play when you're ready to find the answer.
So now we have a different type of 3D shape. Let's test your skills on this new shape on parts A and B. So write down this square-based pyramid, attempt these parts, and press pause and press play when you're ready. The diagram shows a square-based pyramid A, B, C, D, and a vertex V. Alright, so obviously we can see these vertices all over here. The top bit is directly above O, the center. Now the angle that face VCD, so VCD is this triangle here on the right, okay? If you look at that, the angle that makes with the square base ABCD is 53 degrees. Calculate the height of the pyramid. So let's try to visualize this. Remember, in 3D trig, always look at your triangle on your 3D shape first, and then convert this to a 2D triangle on paper. Now, if we look at this, let's pick a color over here, or in fact, let's use a bit of common sense and say you have to discover that this this VCD plane, this triangle, the slope that, or the angle rather, it makes between the slope VCD and the flat plane, which is the square, is 53 degrees. Okay, so let's call this M over here for midpoint, and what we'll do, we'll create a triangle to show this. This is our triangle. Here, alright, so we can see this. This is our triangle within this, a 2D triangle. This is the right angle over here. Let's try to write this down now, because you want to find out the height of this. And this is exactly what's going to help you do this. So part A, we'll draw that down. Let's jot this down. We have this. This and this. Is important to get the shape right. That's on the actual 3D shape and the actual vertices V, O, and M. M is just the midpoint of that. This is 53 degrees, if that makes sense. That will help you understand it now. VM is simply the halfway between, you know, C and D. And then we've got now, we want to find out VO. Now, do we know OM? Well, we do, because if this is a square, the full base of the square is 9. This must be 4.5. So to find out, therefore, VO, this bit over here, we have to use a bit of trigonometry, and this will simply be tan, because we've got O, A, and we've got the angle over here, H. So what we'll do is times this. We'll do tan 53 times 4.5 with the calculator. So we get that to 3 significant figures, 5.97 centimeters would be the answer to part A. So again, use those techniques we've done. Find it on the 3D shape first, convert it to a 2D shape, and use this basic concept of trigonometry, tan in this case. So let's move to part B now. Part B involves finding the length of VD. Okay, so VD is his length over here, one of the 4 sloping edges, should we say, VD. Now to find out VD, first of all, let's visualize this. Remember, always visualize this in 3D. Once you can see it on your diagram, we simply plug it into a 2D version on paper. So VD will be this. Now the triangle you need is this: VO, VD, and VO, OD, and VD. Excuse me. So we have a right angle over here, which is VO. That's clearly to be seen. Let's put this a little sign for green. Part A should be actually a little red symbol to signify that. It's going to have different colors here because lots of different things going on in our 3D shape. So this is green now, okay? Now, what do we know from this? So we've got VO for part A. OD we don't know, and simply we need to find out VD. Now, OD is actually half of BD. If you remember from C1, core 1 rather, we kept on saying always find the base, more specifically the diagonal bit of the base, because that serves as a very crucial part for all the other parts that come into question. And this triangle over here, which is BDC, is very important as well for what we're doing, okay? Because BD, if we find out BD using Pythagoras, we simply find out OD by halving it. So let's draw our triangle now, which is BDC. So we do it exactly how it looks on the 3D graph, like this, and like this. We'll call this B, we'll call this D, we'll call this C. We'll label a few things. We'll call this 9 and 9, simply because it's a square. We want to find out BD. And we'll do our right angle as well over here, which is the same thing as this right angle over here. So this will be simply Pythagoras, because we have all lengths known this time. There's no angles. Let's label this A, B, and C. So C will simply be this. A and B, it doesn't really make a difference. So we'll do the same thing over again. It's quite simple. A squared plus B squared equals C squared. So we have, let's cut it short a bit. So we've got BD squared equals 9 squared plus 9 squared. That's C squared equals A squared plus B squared. So BD squared will give you 81 plus 81. So 162. So therefore, BD would be the square root of 162. And BD would simply be 12.73 sig figs, 12.7 over here. Okay, so that's 12.7. OD is the next thing we're looking for, and OD has got to be half of that. That's the whole point of this. Sometimes we need one triangle to move on to the next. So still with part B over here, to find out the length of this, let's draw our triangle now for this. It'll be more clear. VOD. So this is VO, this is OD, and this is the last bit over here, which is VD. Now OD will be half of this 12.7. So half of that, if we do this on the calculator, 6.36. This is already 5.97. How do we find out VD? It's very, very simple. We do the same thing again. So the same thing would be Pythagoras. So let's do that little trick once again. So the trick would be 5.97 squared plus 6.36 squared, and basically we do Pythagoras again, and if you do the whole thing, we're going to get an answer of 8.73. Did that a bit quicker this time. It's the same thing as this bit over here, but that's your answer for VD. So VD is 8.73 for this one over here, and we've color coordinated this red and green, so you know which ones we're talking about. Part B, we have two triangles to get to that, a yellow one and a green one. It's worthwhile putting a yellow one first for that as well. Let's press pause and write this cube down. Let's answer parts A and B on this grade 8 question calculator, 5 marker, and try to use as many of the techniques you have learned so far in this GCSE towards this question. A big hint. Anyway, good luck and press play when you're done with the answers.